Yeah.
Well, yeah, you can see.
Good. I too am happy to be here with the distinguished speakers. That's how I learn a lot of things.
Well, it's other things more like
Okay, learn more. Excellent. And I'm also, I'm excited to talk to you about making insects. They are the little things that run the world. We're losing them. We need to restore them. We are in Georgia, though, so we'll just call it making insects. The lights are coming up again. Why is it? Can we keep those lights down? It's funny that we talked about Edward L. Wilson, biophilia. He's written, I don't know what, 30 books, written a lot of books. He is a brilliant man. If you're looking for brilliant people, look to E.O. We call him E.O.ism fondly. I have been, well, he's brilliant because he's one of the most brilliant biologists ever. Certainly one of the most brilliant entomologists, myrmecologists. He invented the whole field of sociobiology, conservation biologist. He's the only scientist to win 2 Pulitzer Prizes. He still writes a book a year. Okay, there we go. So when E.O. talks, we should listen. And I have been lucky enough to meet him twice in my career. Once was 1982. I just got my job at the University of Delaware, and there was a small conference on social insects in Boulder, Colorado. And it was small enough that there was not a mingling place. So people gave talks, and then during break, they just went outside. And I went outside, and here's E.O. sitting on the curb, and nobody was sitting next to him. So very boldly, I went over and I sat next to him, which is not like me. And he turned and looked at me, he said, "Hi, I'm Ed Wilson. I don't believe we've met." And I said, "No, we haven't met." And we shook and talked for a while, and it was great. Then break was over, more talks, lunch, more talks, then another break. I was E.O.'s bud now, so I went outside, and he's sitting in the curb, and nobody's sitting next to him. So I went over, I sat down next to him, and he turned and looked at me, he said, "Hi, I'm Ed Wilson. I don't believe we met." I met him 32 years later when he was receiving the Ben Franklin Award at the Academy of Sciences in Philadelphia for a lifetime achievement in biology. I also met Ben, but I was more excited to meet E.O., and I did not remind him that we were buddies. So he was being honored for his lifetime achievement, but mostly for his efforts to save life on Earth. He's been trying to do that throughout his career because he loves life on Earth. He also recognizes that we absolutely need it, and one of the earliest papers he wrote about this was this one. It was in the first issue of Conservation Biology back in 1987. That was the advent of the field of conservation. It really hadn't existed before that. And it was called The Little Things That Run the World, the Importance and Conservation of Invertebrates. And most of those invertebrates, of course, are insects. And he had a very simple message. He said, life as we know it is going to disappear if we lose our insects, because life as we know it depends on insects. If we lose insects, we will lose almost all of the flowering plants, and that will restructure the terrestrial habitats on planet Earth. So many habitats depend on, so many food webs depend on flowering plants that without them they would crash, which means we would lose our reptiles, our amphibians, our birds, our mammals. The biosphere would start to rot because the insect decomposers that rapidly turn things over would be gone, and it would only depend on fungi and bacteria to move nutrients along. And of course humans we do as well. So it was a very somber message, but this was 1987. It was fairly theoretical. Nobody was worried about losing insects because everybody knew insects were everywhere. And besides, if we depend on insects, why do we have National Insect Killing Week? Now that was 1929, but let's face it, we have National Insect Killing Day every day. You see an insect, you gotta kill it, and that is the message. It's springtime, and I'm sure you're hearing the advertisements from pest control people. Insects are here, I will come to your house and I will kill them all. Doesn't matter what they are, I will kill them because that's what we do. Well, even if we kill all the insects at home, and even if we kill all the insects in agriculture, we still don't seem to worry about losing our insects because we know they're very common in our natural areas. or at least they were. And there are a couple reasons, two reasons why that is no longer true these days. And this is the first one. We don't have very many natural areas anymore. We're pretty much everywhere. Most of those natural areas are not natural. And we've changed most of the world into cities, which are not designed to support insects, into suburbs, which are not designed to support insects. Even our rural areas, people go to the country, that's not designed to support insects. And of course, agriculture is not designed to support insects. Let's just talk about rangeland. We have 770 million acres of rangeland in the US, which is, 20 times larger than the state of Georgia. It's a lot of land. Most of it's overgrazed, like you see here, particularly in the West, and it's not designed to support insects. As a matter of fact, food production on planet Earth now claims about half of the terrestrial land surface on planet Earth. And that's not designed to support insects. So that's number one reason why we don't have as many insects as we used to. Number two reason is that the natural areas that are left aren't so natural anymore. They are invaded almost everywhere with plants from someplace else. Mostly plants from Asia, or down here you get some plants from South America. And those plants are not able to support our insects very well either. This is White Clay Creek State Park. It's a park I drive by on the way to work. And every bit of green you see in that picture is a plant from Asia. I took that picture in March, and in March, plants from Asia leaf out before plants from North America. So it's a great time to look at your natural areas and see what's native or not. And you can see that right now driving around here, all that green you see is privet or calorie pear. Those are plants that are not supporting our insects. So we are winning this war against insects, even though it's undeclared. The good news is we're starting to recognize this. This is the third time that the New York Times has carried articles about insect declines globally. So this one was November, just before Christmas, which is good because we can't solve a problem if we don't recognize that it's there. And up to this point, we have not recognized that it is there. Now people are starting to measure the declines. That's the first thing scientists do, which is a little frustrating to me. We know they're declining, let's try to fix it. Instead, we're going to measure it. We're going to see how it declines. So here's some stats from North American native bees. These are bumblebees. 50% of our Midwestern native bees have disappeared from their historical range in the last century. We have 4 species of bumblebees that have declined 96% in the last 20 years. So they're still there. They're not extinct. But 96% decline means they are functionally extinct. They are not performing their role in their ecosystems anymore. There are 3 species of bumblebees that are extinct. They're gone. And we have 25% of our bumblebees at risk of extinction. And bumblebees are generalist pollinators. They ought to be doing just fine because they can go to a lot of different plants. We've got 4,000 species of native bees, and an awful lot of those are specialists. So what's happening to them? We're not measuring that. They are measuring things better and more in Europe. 30% of our European orthopterans, grasshoppers and katydids and crickets are facing extinction. 30%. This is where a lot of the data has come out of Germany. 79% decline in flying insects in Germany since 1989. They've already lost completely 46 species of moths and butterflies. And the big one, see, I even have a pointer here. Invertebrate abundance has declined globally 45% since 1974. So the creatures that keep us alive are disappearing. And I notice none of you are running around pulling your hair out because we humans are incredibly bad at reacting to risks to ourselves that we consider to be long-term. So, well, if it's long-term, we don't really care. What if I said your bank account has just declined 45%? You'd react to that, so I'm still trying to get my head around why we don't react to these things. We are very good, though, at reacting to the fate of other animals. We have a lot of maternal instinct. We care about other creatures. So I want you to pretend that you are another creature. I want you to pretend that you are this bird. What is that bird? Magnolia warbler, yes. Imagine you were this magnolia warbler, and you have just finished overwintering, spending the winter in the Tallamy Mountains of Costa Rica, and you are now going to fly back north so that you can breed. which means you're going to migrate. Well, you're going to undergo the behavior that is the most dangerous thing you will ever do in your life. Migration is incredibly dangerous. Predation risks are high. You're going to fly across the Gulf of Mexico. If you meet a weather front, chances are good you're going down in the ocean, and that's the end of that. If everything goes well, it's physiologically extremely taxing. You're going to lose 35% of your body weight as you're flying across the ocean. And then, of course, when you hit land, you can't keep losing 35% of your body weight. You've got to gas up again. So when you stop at stopover points, you have to put on between 35 and 50% of your body weight each time you stop during your migration. And what are you doing? You're eating insects. You're migrating to begin with because you're an insectivore. There aren't enough insects in North America during the winter. So that's why you went south. So you might want to ask the question, if migration is so dangerous and so physiologically taxing, why do birds migrate? Why bother? Well, like anything else, you migrate because the benefits of migrating are greater than the costs. Otherwise, it would not have evolved once, and it has evolved 386 times. So there must be huge benefits associated with migrating. What are those benefits? They all start with the great flush of foliage that comes out in the temperate zone in the spring. You know, there's no green out there all winter long, but as spring moves along, the leaves pop out, and with that flush of leaves comes a giant flush of insects that eat those leaves. And that flush of nutrients for breeding birds does not happen in the tropics. The tropics are much more constant. They do have a dry season and a wet season, but it's very local. And you do get little migrations locally, but this huge flush of insects does not generally occur in the tropics. So if you're an insectivore and you need insects to feed your young, and here's a lot of insects up in the temperate zone, if you learn to fly north and take advantage of that bonanza of resources, you're going to be able to produce more young. And that is why birds migrate. If they stay in the tropics, they can make 2 to 4 young every year. If they fly north, they can make 3 to 6. And that added reproduction is what justified the cost of migration. So let me emphasize, the cost of migration is justified because there are so many insects in the temperate zone. Or there were when migration evolved. How many insects are we talking about? You've all heard the chickadee story in the past, and that's just, we've measured chickadees, but there are 10 or 12 birds that have been measured. They all require thousands and thousands of insects to rear one clutch. 6,000 to 9,000 caterpillars to make one clutch of chickadees. It's a tiny bird. So we're talking about a lot of insects required to service the reproduction of millions and millions and millions of migrants that come north every year. So again, when migration evolved, there were a lot of insects that they were the selection pressure that favored migration. So the question is, are there still enough insects up here in the temperate zone to justify the cost of migration? Because those costs are still there. And the answer is no. At least every time we measure, there are not enough insects. For 2 reasons. We still kill them every place we go. And we also, in a large scale, have traded the plants that make those insects for the plants that don't. This is where Native Plant Society comes in. Native plants make more insects than non-native plants. So I'm going to share one bit of data with you, just to show you how completely devastating an invasion of non-native plants can be. We did a study in agricultural hedgerows in Maryland, Delaware, and Pennsylvania that were invaded with non-native plants. So there's a typical hedgerow. It's got a lot of autumn olive and multiflora rose and Japanese honeysuckle and bush honeysuckle and porcelain berry and Callery pear and barberry and everything else. Privet, we don't have as much privet as you do, but most of the hedgerow is our plants from Asia. And what we did was we simply counted in a standardized way the caterpillars that are in hedgerows like that, and we compared them to caterpillars that are in hedgerows that are not invaded. The real trick in this study was finding hedgerows that were not invaded. We did finally find 4 of them, and we were able to compare. And what we found is that there was a reduction, 68% reduction in the number of caterpillar species in the invaded hedgerows. And remember, the invaded hedgerows weren't 100% non-native. There were some native plants in there. That's where you get a little bit of caterpillar production. We have 91% reduction in the abundance of caterpillars, and a 96% reduction in the biomass of cows, the amount of food that is available for the birds that are trying to breed there. So only 4% of the food left. That obviously is not enough to provide the thousands and thousands and thousands of insects required for these migrants to breed. And this doesn't affect just a few obscure birds. We're talking about 386 species of birds in North America that are neotropical migrants. And so many of them no longer have enough insects to make that 3 to 6 offspring once they get out there. They might make 2 to 4 again, or 3 to 5 or something, but it's not enough to balance all of those costs. What are these birds? And they're all the birds that we know: the swallows and the swifts, the orioles, hummingbirds, our vireos, our tanagers. They're all migrants. Our bunnings, our flycatchers, our thrushes, our warblers. All the warblers are migrating. Bobolinks. And that is probably why we have 432 species of North American birds now threatened with extinction. That's a measure from the State of the Birds Report 2016. Every year they measure something else, and that's the last time they measured extinction threat. And that doesn't mean that there's only 5 individuals left of each one of those species. We have finally recognized that the signal for impending extinction is the rate of decline of a population. So 432 species of North American birds are declining really steeply. And I hear people say, we have to slow the rate of decline. No, we have to stop the rate of decline and increase them, or they will continue right to extinction. We have 1.5 billion fewer breeding birds today in North America than we had just 40 years ago. And this is an example of shifting baseline. I know everybody in this room is younger than 40 years, so you don't remember a time when there were 1.5 billion more breeding birds around. So when you go outside and it's quiet, that's normal to you. That's all you've ever known. But there really was a time when we had a lot more birds around. Let me remind you that a billion is 1,000 million. We're talking about a lot of birds that aren't here anymore. And of course, if you eliminate insects, you eliminate the things that eat insects. We've talked about birds, but it's not just birds that eat insects. Insects are a critical component of almost every terrestrial food web that is out there. All spiders eat insects, or they eat the spiders that ate insects. So if we lost our insects, we'd lose our spiders, we would lose our frogs and our toads and our amphibians, all the amphibians, our newts, because they all eat insects. Our lizards eat insects, our bats eat insects, our rodents eat insects. You might say, well, rodents eat seeds. They do, some of them do. Only when they can't find enough insects. And the reason they're eating insects is that insects are really good food. There's some studies that have shown pound for pound twice as much protein in insect meat as there is in beef. And insects have organs in their abdomen called fat bodies that are loaded with lipids, high energy compounds that allow these little guys to grow quickly, reproduce quickly. And of course, if you're a mouse, that's what you want to do, because there's a lot of things that want to eat you. But it's the same reason that larger organisms are eating a lot of insects. They're just really, really good food. The skunk is digging up your yard to get the grubs in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. Foxes, things we don't think of as insectivores, eat a lot of insects. 25% of a red fox's diet is insects. A full quarter of its diet. 23% of a black bear's diet is insects. So it doesn't matter how big you are, you still need insects. And even if you don't eat insects, you need insects. This is a sharp-shinned hawk. It's a bird predator. And you might think, well, I can get rid of all the insects in my neighborhood and I'll still have sharp-shinned hawks. But think about it. If you get rid of all the insects in your neighborhood, you've gotten rid of all the birds, and that's what he needs. So he needs insects indirectly. Same thing with the garter snake. It's not eating a lot of insects, but it's eating the frogs and toads that ate the insects. Again, they eat them indirectly. So a world without insects is a world without biological diversity. And that's exactly what E.O. was talking about. And he went on to remind us that a world without biological diversity is a world without humans. Which is why it ought to be number one on our list of things we're concerned about. Not what the outfit of Serena Williams is the next time she plays tennis. That's what's in the news. Okay. our only viable long-term option to living on this planet sustainably is to maintain the natural world that sustains us. We don't have another option. It is not an option to live on this planet without sustaining ecosystems. So how are we going to do this? I keep thinking about how we're going to do it, and this is my latest idea. 85.6% of the U.S. is privately owned. 83% of the entire country is privately owned. So we're going to do it on private property. We're going to do it where we live, where we work, where we play. We're going to do it at your house. That's where we're going to do it because we occupy such an enormous amount of space in North America. And it doesn't mean we're going to ignore our parks and preserves. They are vitally important. That is where our biodiversity is huddling right now, hoping we expand them. Who's in between those parks and preserves? We are, and we're going to connect them by restoring the land that's in between them. So we're going to start with a property like this. We need to save insects. We need to make insects on a property like this, which of course is not designed to do that. But we must. We can turn this type of property around. These are houses down the street from me. This is what it looks like where I live. We've got to conserve life here, everywhere, or we're going to lose it. And again, not an option to lose it. Which means we have to raise the bar about what we ask our landscapes to do. In the past, we have asked them to be pretty. We're good at that. And I'm not proposing that we give that up, but we need to add what we're asking our landscapes to do. So in the past, we have considered plants to be just decorations, which means you go out to the nursery and you find the prettiest plant so you can decorate your yard in the prettiest way. So maybe it could be a screen or an anchor or a focal point, but all of our focus has been on the aesthetics of our properties, and we've done that for more than 100 years. But when we consider plants to be only decorations, then when we landscape, that equals ecological destruction. And again, that's what we have done. That's why we're in the mess that we're in right now. We could find pretty plants that also have function, that also support food webs, that protect our watersheds, that do all of the ecosystem services that keep us alive on this planet, that maintain complex natural enemy communities, that support our pollinators, sequester carbon. These are the things that we have to do at home now. And when we add function to plant choice, when we're landscaping, then landscaping becomes ecological restoration. And I see this as the future. You know, the past 20th century landscaping, we're not going to do that anymore. That's not working. So we're going to do 21st century landscaping. So people clinging to 20th century, just saying, you know, that's all, you got to get into it. 21st century, that is the future. It's really our only option. What does this have to do with making insects? We cannot restore ecosystem function anywhere if we don't have the insect populations that run those ecosystems. So we have to make insects. How do we do that? What does it take to make insects? Well, it takes the same thing that it takes to make any living thing on this planet, and that is energy that comes from the sun that is fixed by plants through photosynthesis. If you're looking for a miracle on planet Earth, look at photosynthesis. It allows us all to eat sunlight. Without plants, it'd be tough to do that. So in order to make insects, first we need plants. Which insects are we going to make? There are a lot of insects out there, and we simply cannot make all of them at home. We got 3 to 4 million species worldwide. That's the latest estimate, and they're estimates because we still haven't described all of them. We've only described some like 1.2 million. 164,000 described species in the U.S., but I can still go out into my yard and find a species that is not described. So who knows what that figure really is? A lot of species, and we're not going to make them all at home. So which ones should we make? Well, I think the two most important groups of insects that we really need to focus on are the insects that maintain plant diversity and the insects that take the energy from those plants and deliver it up the food web. So the ones that contribute the most energy to food webs. And of course, I'm talking about pollinators, and I'm talking about caterpillars. We hear a lot about pollinators, not that much about caterpillars. So who says these are the two most important groups? I do, and I'm giving this talk. So somebody out there is going to argue, oh no, there are other important groups. There's a lot of important insects, but this is what we're going to focus on today. So pollinators, you know, I only have an hour. And in order to tell you how we're going to restore pollinators, I would need an hour and a half. But there's a lot of talk about pollinators. I'm sure you've had people in talking about pollinators. So we can deal with that another time if you want to. But today I'm going to focus on that group that is not discussed very much, and that is how we make the group that is transferring most of the energy from plants to other creatures. Most animals do not eat plants directly. They eat things that eat plants, and most of those plants are insects, and most of those insects are caterpillars. And I'm going to use bird food webs as an example to show you how prevalent caterpillars are in food webs. 96% of our birds, when they're rearing young, and that's the important time, if you don't reproduce, pretty soon you don't have any birds. So I don't care what they do the rest of the year, when they're eating seeds and berries. But when they're rearing young, they are rearing their young on insects, 96% of them. And most of those insects are caterpillars. So let's explore briefly why caterpillars are so important in bird food webs and the food webs of other creatures. And there are a number of reasons. One is that most caterpillars are soft. Think of them as a sausage with a very thin wrapper around. The wrapper is their exoskeleton. It's not digestible, but it's very thin. So they get a lot of food and very little exoskeleton. And that means you can stuff a caterpillar down the throat of your baby without fear of injuring it. And if you've ever watched a parent bird do that, they're pretty rough. It's like a plunger. They just They're also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. There are some smaller birds that chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're nutritious, high in protein, high in fat, and they're relatively low percentage of chitin. That's that sausage analogy. Compared to a beetle, which is like a little tank, it's got a lot of chitin, a lot of undigestible material, and there are often a lot of sharp edges there, even though beetles are very common. Might be one of the reasons beetles are very common. And it turns out that caterpillars are the best source of carotenoids for birds when they are breeding. And I'm mentioning carotenoids because they are essential components of our diets, yet we don't make them. Vertebrates cannot produce their own carotenoids. They have to get them from plants. Only plants make carotenoids. And that's why my wife Cindy says I have to eat my carrots to get my beta-carotene, I keep my tomatoes to get my lycopene, my whatever that is up in the corner there to get my lutein. And she makes sure I get all that stuff because if I have a lot of carotenoids, they stimulate my immune system. I'm just generally healthier. They are antioxidants. They run around our body and protect our DNA from oxidative damage, and that's a good thing. They improve our color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality. Who doesn't need that? Improve sexual attractiveness. Now we're talking about mostly male birds, like this prothonotaric warbler, is taking carotenoids and building pigments out of them, and then he puts the pigments in his feathers. So he's bright yellow because he's had access to lots of luteins. And the brighter yellow he is, the more ladies he attracts. It's a good thing. Okay, this is the distribution of carotenoids in different types of invertebrates, insects and spiders and worms and other things. And it might be a little hard for you to see. The first two bars, first bar is sawfly larvae, indistinguishable for most people and birds from Lepidoptera caterpillar. They're the highest Lepidoptera caterpillar in this study, a little bit lower. But so let's average these and call them caterpillars. Say it's around 65. Compare that to spiders. Spiders over here, they're what, 5-6 times more carotenoids in caterpillars and spiders. And spiders are really important components of bird food webs. Then you get down to worms. Everybody says birds are eating worms. So look, there's almost no carotenoids in worms. So how does this influence bird foraging? If you look at bluebirds and look at the prey choice that they have. Bluebirds are thrushes. They spend a lot of time foraging on the ground, so they're not up there in the trees gleaning a lot of caterpillars. Yet still, caterpillars are the number one item on their list. So this is the total carotenoid content of the prey item compared to how frequently it was taken in the diet. And this is based on, I don't know what, 50,000 feeding records of bluebirds. We had cameras up at the nest that took a picture every second and a half. So had a lot of pictures to go through. So it's a very robust data set, but shows, look, they are picking there's a very direct correlation between the carotenoid content of the prey item and the frequency of that prey item in the diet. So the point is that for most birds, caterpillars may not be optional parts of the diet. They're probably essential parts of the diet. And that means if you don't have enough caterpillars in your environment, you're not going to have very many breeding birds. So our goal is increasing the number of caterpillars. Let's talk about our yards. How do we do that in our yards? Well, we add caterpillars to our yards by adding the plants that make them. It's simple, very simple. Except this is the part that's not exactly so simple. All plants don't make caterpillars equally, so we have to add the right plants to our yards if we want to make caterpillars. Why is that? Well, remember that plants really don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they loaded their leaves with nasty tasting chemicals. Secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? Well, 90% of the insects that eat plants are what we call host plant specialists. And you've heard this a number of times, but it's kind of like promoting diets. You have to hear it over and over and over again. They are host plant specialists, and they can only develop on the plant lineage that they have experienced enough exposure to that they can develop these specialized adaptations to allow them to get around the chemical defenses of that plant lineage. They develop enzymes and behavioral adaptations and life history adaptations that allow them to eat this particular plant lineage without dying, because those chemicals are really effective. And that's why the Bradford pears that you see blooming right now are not going to support the insects that you need. They're from Asia, and they have not been here long enough for insects to adapt to. How long does it take? Because they've been here a while. We're talking about tens of thousands of years. Minimum. That's what the data suggests. So believe me, it's not going to happen before they force a lot of those insects out of existence. And that's the same thing with bush honeysuckle and burning bush and all the other things, privet that we have loaded our landscapes with. Let me give you an example. I'm going to use the monarch as an example because you already know half the story of the monarch. You know, great national push to save the monarch. We need to save the monarch because it's a host plant specialist, and we've taken away its plants. We've taken away milkweeds. They're specialists on milkweeds, and milkweeds protect themselves with cardiac glycosides. They are relatively toxic plants, and that's why we don't go outside and eat milkweeds. And if we did and ate enough of them, it would stop our hearts. That's what cardiac glycosides do. It doesn't stop the heart of the monarch, and they do have a heart, by the way, because they've got the physiological adaptations, the enzymes that store and excrete and detoxify cardiac glycosides. What about the sticky latex that is in milkweed? That gives milkweeds its common name. When you break open a milkweed vein, you get this white goo that comes out. If you get it on your finger, usually wipe it off right away, but if you don't wipe it off right away and let it sit there, it'll gel. It turns into a chewing gum-like substance, and that is a defensive property of the latex sap. If a caterpillar crawls on a leaf and starts to eat a milkweed vein, it gets white goo all over its mouth parts, it glues its mouth shut, and then it starves to death. Very effective defense. But of course, we do know that monarchs do exactly that. They crawl on the milkweed leaves and they eat them, and it doesn't glue their mouth parts shut. Why not? How do they get around that? Well, this is what you can watch. You plant milkweeds in your yard, you can watch them. First thing the caterpillar will do is crawl into a new leaf. It typically goes to the end of the leaf and starts to eat. And if any little bit of latex sap starts coming out, it'll stop eating immediately, turn around, go back up the leaf, maybe 2/3 of the way, and it starts to chew through the midrib. And it chews until it has completely severed the midrib. And that's the key. The midrib has the veins, the vascular system that pumps the latex sap from this end of the leaf to that end of the leaf, and it's now blocked all the transport of latex sap. So the caterpillar can turn around, go back down to the end of the leaf, and eat the leaf without any latex sap coming out at all. So that's a behavioral adaptation, not a physiological one. And it's very simple, just chew through the midrib. But monarchs are the only ones that figured that out. The other types of insects have not figured out how to do that. And that's the upside of specialization. The monarchs have spent such a long time, close association with the genus Asclepius, with the lineage in which Asclepius is included, because monarchs can eat milkweeds from anywhere in the world, that they have the adaptations that beat that lineage at its own game. The downside of specialization is that now that's all they can eat. So by specializing on the defenses of Asclepius, they have not spent any evolutionary time building defenses against the tannins that are in oaks, or the cucurbitacins and cucurbits, or the nicotine in tobacco, or the cyanide in cherries. Every plant lineage that is out there has defensive compounds, and the monarchs can only deal with one. There are 2,137 plant genera in North America, and the monarchs can only eat one. That's host plant specialization. And of course, that means if you take away that one plant genus, you lose your monarchs. And as of 2013, it looked pretty bad for monarchs. Only 96, we lost 96.4% of the monarchs that were around in 1976. So we launched this big, monarch, Save the Monarch workshop or effort throughout North America. It may be working. The overwintering populations in Mexico are doing real well. Numbers are up this year. If they can start migrating north without some big winter storm down there knocking them out, the monarchs will be on their way back. We have to do that a number of years. But that shows that if you put the plant back, you can save these insects. Why are we worried about monarchs? Why do we care about monarchs? Because they're pretty. That's it. If that was an ugly moth, we wouldn't even notice. But remember, 90% of the insects out there are host plant specialists, just like the monarch. We got to worry about those animals too. We have to put their plants back as well. So plant choice matters. That is the message here. If I want to have the Pandora Sphinx in my yard, I got to have Virginia creeper, because that's what it eats as a caterpillar. It's a beautiful moth. I do want the Pandora Sphinx at my house. If I want the tulip tree silk moth, I need tulip trees. If I want the Luna moth, rather, that specialized host plant is sweet gum. Zebra swallowtails only on pawpaw. Eight-spotted forester moth only on native grapes. Viburnums produce a lot, like the green marvel. Goldenrod is a top-producing herbaceous plant. 110 species of moths on goldenrod, like the goldenrod or the brown-coated owlet. Even poison ivy, beautiful utilia on poison ivy. You know when you get poison ivy? When you try to pull it out. It will not chase you down the driveway. And it makes wonderful berries that the birds really like in the fall. Sculptured moth is on persimmon, the Hebrew on black gum. Our beleaguered ashes produce a number of sphinx moths, like the beautiful fawn sphinx. Maple's important trees, like rosy maple moth. This is the most, I think it's the most spectacular moth in North America, the royal walnut moth, and it has the most spectacular larva, a 7-inch long hickory horn devil on walnut and hickory. Double-toothed prominent on elm. Witch hazel produces the witch hazel dagger moth, and every one of these plants produces a lot more than that. I'm just giving you examples. Pines are important, the imperial moth, even native clematis will give us the spotted thyrus. Ironwood, the two-tone ancillus, buttonbush, the lost owlet. Native willows give us the herald. Coral honeysuckle, the native honeysuckle, gives us snowberry clearwing. Evening primrose moth, believe it or not, is on evening primrose. Showy emerald on sumac, and I'm not talking about poison sumac. That's a plant of the swamp. I've never seen poison sumac. I'm talking about smooth sumac, staghorn sumac. Things, if you're looking for a soil stabilizer, that's what you use. You do not need a plant from Asia to stabilize your soil. Now we get to the real powerhouses like black cherry, our native prunus, that give us the white furculum, the crocus geometer, the io moth, the lovely cecropia moth, colorful zale, the tufted bird dropping moth, and I can't imagine anybody not wanting the tufted bird dropping moth. The paddle caterpillar. Ask your kids what those paddles are for. They have a function. They're not decorations. Let them think about it. Come up with hypotheses. And I'm not going to tell you what they're for, so you have to think about it too. It's the same reason that the filament geometer has these hydra-like extensions. Small-eyed sphinx. These guys are all on black cherry. Harris's three-spot that wears an umbrella of its head cuticle head capsules. Nobody knows why it does that. The most powerful plant of all, of course, is the oak. Genus Quercus. Give us the hag moth, the red-watched promenade, the white-dotted prominent, the spiny oak caterpillar, the skiff moth, the white-blotched heterocantha, the oak skeletonizer, beautiful solitary oak leaf miner, crowned mucolatrix, half-oval ancillus, pink-striped oakworm. This is my favorite caterpillar, the spun-glass slug caterpillar, plus literally hundreds more on your oaks. Where did I take all these pictures? I took them in my front yard, and that's what my front yard, not my backyard. I don't like the term backyard habitat, because that implies everything we're talking about is so ugly, we gotta hide it in the backyard. You can have an oak tree in the front yard, it'll be okay. That's what my front yard looked like when we moved in. That's what it looked like a few years ago. We put the plants back. It was mowed for hay before that. We put the plants back. And I'm counting the moss species now on our property. It's a big job. I'm up to 879 species of moss that are there because we have put the plants back. We put witch hazel and oaks and persimmon, all of those plants we planted purposely on our property. And we tolerated an awful lot of plants that people consider weeds, like black cherry, like native grapes and tulip trees. Nobody likes tulip trees. Virginia creeper. We tolerate our poison ivy, and we get that beautiful utilia and several others. Greenbrier, dodder. How many people are planting these plants? But every plant lineage you put in your property is going to bring more moths. And when you bring more moths, more caterpillars, notice I'm not saying butterflies. Butterflies are bad-tasting, day-flying moths. So they're not huge in food webs because they don't taste good. That's why they're flying around during the day. But then you also get the birds that rely on those moths. We added wood thrush to our breeding bird list last year for the first time because we have Virginia creeper making lettered sphinx. And our property has grown up to the point now where a bird that loves to live in the woods now thinks it's okay. And our trees are 18 years old at this point. Indigo bunting, because we have alders making ruby quakers. We have chipping sparrows because we have black walnut making gray edge bommalocas. We have field sparrows because we have oaks making red line panapodas. We have tufted titmouse because we have black cherry making dowdy pinion. Phoebes nesting on the light above our front door because we have native grasses making skippers. There's our friend the Carolina chickadee because we have tulip trees making tulip tree beauty. We have white-eyed vireos because we have spice bush making spice bush swallowtail. House wrens because we have hickories making copper underings. Bluebirds because we have sycamores making drab prominence. We have 55 species of breeding birds at home now because we put the plants back. And you can do that too. You can do that too. Which plants should you be sure to put in your landscape? There's now a handy-dandy tool that we've created. It's on the National Wildlife Federation website called Native Plant Finder. I already know it's not perfect, but it's a whole lot better than we had. If you put in your zip code, the ranked list of woody and herbaceous plants will pop up for your county. And it's pretty good for Georgia. There are a few states where we got some issues, but Georgia's not one of them. Pretty good. You're getting a pretty good ranking. And when we did this, we now have a ranking of plants for every county in the country. And it's a very powerful data set that allowed us to see this pattern. It turns out wherever you are, only about 5% of the plants, and they're native plants, are making about 75% of the food. So you have very few plant lineages making most of the food. We started calling them keystone plants. And what this does is change the debate. This is now a nuance. It's no longer really a debate about native versus non-native. I got an email the other day saying, oh, read this blog. It says that ginkgos were native to North America 7 million years ago, and therefore they're native plants. Yeah, they were 7 million years ago. All the interactions they had 7 million years ago are gone, and ginkgos don't support anything now. But rather than argue about what's native or what's not, we should be thinking about what is productive and what's not. I can build a landscape at 95% of the available native plant genera, and it'll only make 25% of the food if I don't pick those keystone genera, those keystone plants. So beat native isn't good enough. You've got to beat the correct native to build the backbone of your food web. And then you can have all the diversity of these other plants. Something to think about. And if we don't include highly productive plants in our landscapes, we are not fooling the birds. Here's a little bit of data from my PhD student, Desiree Narango, who is now graduated. She's in a postdoc at the University of Massachusetts. And she studied Carolina chickadee breeding in the suburbs of Washington, D.C. And her question was very simple. She said, what is the breeding success? How many babies did they make? What is the survivorship, the breeding success of chickadees in relationship to the plants in the landscape in which they're breeding? And she could control that by putting up chickadee boxes. Chickadees are tree hill nesters. Tree hills are always in short supply, so if you put up a chickadee box, they will do their best to use it. And she could put it up in different yards that had different percentages of native and non-native plants. So this is one example of one territory. This is one pair of chickadees. The red line represents the foraging territory of that chickadee. They did all their foraging, 95% of their foraging within that red line. The star is where the nest box was. So notice they're foraging. It's about 50 meters from the nest. It's not very far from the nest. And these are the trees that they did 95% of the foraging on. If it's hard to read, it's basswood, sweet gum, American elm, black cherry, and 2 species of oaks. So we're all the natives in this suburban landscape inside the Beltway in Washington, D.C. Let's also look at the plants they were not foraging on, and it's all the plants from Asia. Japanese maples and silk tree, our friend the ginkgo, and black poplar, crepe myrtles. How do they know where these plants are from? They don't know. And they do go into the ginkgo to look for food. And they go once. They go as many times as you would go to ShopRite if all the shelves were bare. You wouldn't go back. But her work allowed us to compare native landscapes, primarily native landscapes. None of them were completely native, with landscapes dominated by introduced plants. And when they were dominated by introduced plants, they produced 75% fewer caterpillars. So right away, it reduced the amount of food 75%. They were 60% less likely to have breeding chickadees at all. So even though there's a nest box up and a lot of chickadees want to use them, they do have the ability to assess the quality of the landscape as if there is not enough food here, we're not even going to try. If they did try, the nest contained 1.5 fewer eggs. They were 29% less likely to survive at all. The nest produced 1.2 fewer fledglings, and they did it slower. It took them 1.5 days longer. And the nestlings that emerged were lighter, which meant they had a lower chance of success. And you might say, well, those aren't huge differences, but if you put all that together in a population growth model, like this is what it looks like. We're talking about the growth of the population as a percentage of the non-native plants in the landscape. The dotted line you see up there is that's replacement rate. That is the rate at which the birds have to breed in order to replace the adults that are lost each year. So they have to have that many chicks or the population starts to decline. If you have anything above the dotted line, you have a growing population. Anything below the dotted line, you have a shrinking population. Unsustainable. So you can see that when you've got 30% or more non-native plants in the landscape, you had a declining, unsustainable chickadee population. So what's good about this is, first of all, now this is the first time this has been better for any bird anywhere. And it shows, yeah, the plants you put in your yard really do impact the birds that are trying to breed there. But it also gives us a target. If you need your crepe myrtle, and you can't live without it, you can have it as long as you have enough native plant biomass, particularly those keystone genera that are going to balance the fact that that crepe myrtle is not doing anything. But when you have more than 30% non-natives, when everything's a crepe myrtle or a camellia or a ginkgo or something else, the chickadees can't do it. And if chickadees can't do it, nothing's going to be able to do it, because chickadees want to do it. They'll eat out of your hand. Remember, they can't feed their babies seeds. Putting out a bird feeder isn't going to help the chickadees reproduce. So how we plant trees. We're still making caterpillars here. And how we plant trees turns out to be very important for moth survival. Let's look at a few stats from Pennsylvania. There are 511 species of caterpillars that develop on oaks in Chester County, Pennsylvania. That's where I live. What is it? 480 species fall from the tree in order to complete their life cycle. They pupate or they spin a cocoon off the tree. There are a few species, like the polyphemus moth here, that do everything on the tree. They will spin their cocoon on the tree, spend the winter there, complete their life cycle there. But most of the species need healthy habitat underneath the tree in order to complete their life cycle. And so there's a little cocoon spun in leaf litter. Unfortunately, of course, this is the way we treat most of our trees. This is not happy habitat under the tree. It's compacted soil. When the caterpillars fall down, I don't know what those are, but if they're all oaks, they might be making a lot of caterpillars, but none of them are going to get through to adulthood because they can't tunnel into that compacted soil. They get mowed by the mower. They crawl into the street. There's no leaf litter to spin your cocoon in. And of course, the cement landscape is even worse. So this is a typical landscape, that giant liner that we're not sure how well they survive under there. But this is what you're going for. This is where you build that layer landscape. Put in some shrubs, some understory trees, ground cover, and Rick will talk a lot about this. The moths fall down into that stuff. Nobody's walking in there, nobody's squishing them, and survivorship is going to be very high. Another layered landscape, this is from Alaska with a birch growing out of it. That's Alaskan elderberry. This is where you do your spring ephemeral garden. You're not tramping through there, squishing the caterpillars, but they're down in there. They're very happy. This is where you put your ground covers. This is mayapple or ginger or native pachysandra. Why do we need pachysandra from China? I don't know. Native pachysandra works really well. So pay attention to what you do under your trees, and you can increase moth survivorship. Final thing I'm going to talk about is the fact that security lights on at night, are another major source of insect mortality. Lights at night are now a habit. Remember, we spent thousands of years on this planet without lights on at night, and even the last several hundred years before electricity, we made it through the night without security lights on. And we weren't killing insects then. But now everybody's got a light, and it's on all night long, and the insects are flying in and getting killed. Why they fly to lights, we still don't really know. But they use up all their energy flying around them, or the bats come and pick them off, or they're on the side of the wall in the morning and the birds come and pick them off. It's a death trap for our moths. You can have security lights, but put a motion sensor on it, so it only turns on when the bad man comes. You know, blindly lighting up everything for no reason it's not acceptable anymore because we're losing so many insects. There was an interesting study came out last year from England, Europe, someplace, France I think it was. What they did was they put night vision goggles on, and they counted the moths pollinating plants at night in a field. And they counted them all. Then they erected streetlights in that field. And the number of moths declined 62% as soon as you put the streetlights up. So lights really are a major mortality factor. So the point is, by choosing the right plants, by using a whole lot more of them than we normally do, we got way too much lawn. We've got an area the size of New England in lawn right now. We really could restore a lot of the insect populations almost anywhere. So I'm going to close by returning to where I started, and that is E.O. Wilson. You know, E.O. is busy writing books every year. He's 89 right now. He's writing a book about his own life right now. But in 2016, this was the book he wrote, Half Earth. How many people have read Half Earth? 2, 3, good. Usually it's one or none, you know. E.O. is getting desperate. He's not trying to win Pulitzer Prizes anymore. He is trying to present the science that demonstrates that we need to protect ecosystem function on half of planet Earth, or we're going to lose life. And then he spends most of the book discussing the science that supports that statement. He spends very little time in the book telling us how we're going to do that. Remember, half of the earth is in agriculture, and he's not saying we're going to take that out of agriculture, and we live in the other half. Our 7.6 billion, all of our infrastructure, our 4 million miles of paved roads just in the U.S. You know, the Denver airport is twice the size of Manhattan. We've got a lot of infrastructure out there. It's all in this other half, and now we're supposed to have ecosystem function everywhere. Well, I still think we can realize E.O.'s dream, or come close to it, but we need a new approach to conservation. Our approach to conservation in the past has been to conserve this piece of land, and we're going to live someplace else. It's the humans here, nature someplace else approach. There is no someplace else anymore. So now what we need to do is have viable conservation efforts where humans abound. The UN designates biosphere reserves as places of ecological significance. And that terminology drives me nuts. Because every place has ecological significance. There is not a square inch on this planet that does not have ecological significance. We cannot take giant chunks of the biosphere and say, oh, you don't have to play the game. It's not going to work that way. So every place, including your yards, including yards that look like this, have vital ecological function. So again, where are we going to do this? We're going to do this on private property, which means we're going to do it where you live. You don't have to save biodiversity for a living, but you can save it where you live. And that's a property you can manipulate without any constraints. That's where we should start. This approach empowers all of us. Now we're important components of the conservation puzzle. It shrinks the problem to a manageable level, too. If you think about all the problems the Earth is facing, it gets a little overwhelming. But just look at your own property. Get rid of your invasive species, shrink your lawn, put in those keystone plants, and I will be happy if you do all of that. So as property owners, each of us has the power, each of us has the responsibility to fix this. We have to fix this. So thank you very much.